Hi everyone, welcome back to my YouTube channel. So, about 2 weeks ago I uploaded a video of a powder coating booth that I built. I mentioned in that video about an oven that I also built after the booth. This oven was built to powder coat metal items such as alloy wheels or even metal components up to the size of the oven, obviously. So the reason I bought the oven was because I got my wheels professionally powder coated by a company in my country. I'm not going to mention any names, but the wheels came back. The wheels were brand new, but they were damaged with a chemical, so I got them professionally powder coated and they came back all pitted. Dull, flat, powder being all full of orange peel and dirt. So I contacted other companies in Northern Ireland and I have asked them or seeked advice about can they powder coat wheels, up to a factory finish with no dirt going on it, no dirt in the powder itself, and they says they can't guarantee that. So that was coming from a professional company, so what I decided to do then is just build my own oven and powder coat my own wheels, because I do powder coating anyway for smaller items using house oven. Before this oven here. So the reason I didn't build a bigger oven is because obviously it requires more power and stuff. So it's not even that. If I was to build bigger ovens, then a bigger oven, people's going to be looking work done, and I don't want to be doing work for the public. I only do projects for myself. So this oven is was started in September. It was finished about 3 months ago. Obviously I haven't worked at it every day because of my studies, but all the components is handcrafted again. There's no machines at all used to fold or the joints or anything, and this control panel or this door frame or anything. But what I'm going to do, I'm just going to take the full project outside till daylight and show the quality of the oven itself. I'm going to do a walkthrough of all the components on it, inside and outside. I will also do a demonstration of the tracking system that was built for the oven itself, and the booth. So the tracking system runs from the oven to the booth, and I can run items up to say 200 kilograms on the tracking system from the booth into the oven. The oven can easily hang a quarter of a ton inside. That's what it's manufactured to, rated to. You'll see that in the design process at the end if you want to stay and watch the photos themselves of the manufacturing process. But I can say that that's a very long process. There's about 1,000 photos and there was a lot of work in this oven. As you know by my past videos, I'm really fussy and everything needs to be perfect, otherwise I wouldn't do it at all. So what I'm going to do is I'm going to take this oven outside into the daylight, and hopefully it doesn't rain. And I'm also going to take the booth out. I'm going to line the booth up to the oven. I'm going to demonstrate, after I talk about the components of the oven, running an alley from the booth to the oven and the oven to the booth, and closing the door and all again. And I'm not going to talk about the booth at all because I've done a video 2 weeks ago on that, as I've mentioned. But the oven is really good. It's an industrial oven, obviously. I'll just open the door here, you see. So the oven can go up to temperatures up to 200 and we can go probably up to 300 degrees, but I haven't designed it for it. I've designed it for 250 degrees maximum. I can control the temperature of the oven using a digital stack. The oven is also set up on a timer, so I can walk away when I see the curing. When I see the powder curing of any metal or alloy item, I can release hold, the hold button, and the oven will start counting down. This timer here will cut out. It's currently set at 10 minutes, 600 seconds. Isn't that right? So 600 seconds, and the oven stops. When the oven stops, it doesn't just cut the fan off. The fan continuously, the air keeps turbulating through the oven itself. Make sure the circulation's good. So I can also, I'll just demonstrate it here now. I can hold the time here by pushing the hold button again. I can also reset back up to 10 minutes, depending on where the clock's set at. This clock can be set in seconds, to hours, to weeks, to months. Obviously, for powder coating, it's going to be minutes. So, what the clock does is when the clock hits zero, the elements, there's two elements in this oven, it's 5 kilowatt. The oven cuts off at exactly whatever you set the timer to. The stat keeps the oven up to temperature, which depending on the item, such as an alloy wheel, I would usually set it at about degassing the alloy wheel, I would bring it up to about 240 degrees for half an hour to make sure all the air pockets are released from the alloy itself. But also depending on the density of the metal, the volume, you have to up the temperature a bit. So with a smaller item, I usually do it around 180 degrees, such as thin sheet steel. Or such as an item such as, I don't know, this handle here, if I was to powder coat that. So I'm now going to take the oven outside. I'm going to do my best to line it up to the booth. And I will do a full walk around of all the components. The manufacturing process will come at the end of this video, but be aware, it's very, very long. So if you're only here to see a demonstration of the oven, you probably only need to watch about 3/4 of this video. And that's it. So I'm going to go outside now, and I hope it doesn't rain. I'm praying it doesn't rain because it gives rain, and if it does rain, I'm just going to have to deal with it. So I hope you enjoy. I'm going to show the oven going up to temperature. So when I do a demonstration outside of all the components, I'm going to bring the oven back in, and I'm going to do a close-up of it going from, say, it's obviously sitting at 20 degrees here and now in the oven, and I'm not going to bring that down, that's a blow cool air in it. So I'm going to do a demonstration 20 degrees to 220 degrees, say I'll pick it up that far, and you will see the oven then start bringing it up to temperature, down, up, down. When the temperature falls, it'll bring it up. Outside now, I hope you enjoy it. Okay everyone, two projects are outside now. Oven, booth. There's going to be road traffic in this video because it's going to be quite long. I'm not going to talk about the booth in detail, I'm going to talk about the oven. I'm going to do a full walk around now and see how it goes. Okay. So there's definitely going to be road traffic now, so please ignore. So the project is outside because the sunlight shows all you know, the special features of this project. So the oven is currently running. You can't see because the sunlight is hitting these dials. They're very dim. But I'm just going to go a wee brief walk around to show the project itself. Then I will go into more detail. So 2 hinges, a frame, aluminium panels, all coated on brushed, brushed vinyl, an isolator, 32 amp. The oven income supply is 22 amps, 230 volt supply. So these panels is all countersunked on and riveted with nut rivets. Not rivets, but nut rivets, so there's an even gap nice down here, as you can see. Underneath we have the same thing, all neat panels. Flexi, where the income supply runs into the oven itself. So this oven is 5 kilowatt. There's 2 heating elements in it out of an ordinary house cooker. This control panel, I'm going to talk about it in more detail in the garage when I'm doing a demonstration of the oven going up to temperature. This control panel has a digital stat, a timer, a countdown timer, so you can set that for curing time. So the oven shuts off within say 10 or 15 minutes, or even 20 minutes. And all the way I would keep it on for 20 minutes because it's so dense. This clock timer is currently set at 10 minutes. You have 2 levers here that hold the door closed. This handle is fabricated using stainless 316. These wee brackets and all are also 316, and it is all polished up nice and neat. this door is made out of so many sections. It's a hundred, sorry, what is it? 3 inches thick, 75mm wide. There's a mirror polish, as you can see here at the front, because that's all I had at the time. The one's picking up now, so hopefully it doesn't disturb the sound of me. So, this mirror finished is 2mm plate, and this here is a 75mm channel. The door is welded in 4 places at each corner. It's mitered with grinder and welded with aluminium welder. Sanded, and so it needed to be V'd so the welds didn't break. So the door needs to be strong, obviously. This whole hinging mechanism here is quite strong. Very strong, actually. If you watch the demonstrations of the video at the end, you will see the process behind this, the manufacturing process. There's a lot going on behind the panels. So you have glass to see the wheels or anything starting to cure. I'm going to open it up here now. So the oven is currently running. The oven's set at 10 or 20 degrees just until I get it back in the garage. So the door opens right round 180 degrees, so it moves out of the way of the spray buff or just obstacles of you putting anything in the oven. In the oven here we have multi-board on the inside. There's a lot of making in this oven. There's a lot of hidden items in this. If you don't see it, you'll see in the manufacturing process at the end of the video. There's the probe, the temperature probe for the stat. You have two runners here that you can hang a grid on, they hang items on, they powder coat. At the side of the oven there you have 2 lights. This backing panel is also made out of mirror polished stainless because that's all I had at the time. And as you can see here, you can see the folds. There's about 8 tracks with the grinder, and it is folded nice and neat. That backing panel is there to keep the elements from cooking the back of the oven, deflect the heat away from the back of the oven. Otherwise, it will just burn this multi-board because it's much warmer around the heating elements than it is around here where the hot air is. So as you can see, there's round plates at the side of the oven here. These round plates hold the multi-board to the insulation. There's a rubber bead right around the door, keep the heat on. The rubber bead sits against this orange frame here. Sorry, the rubber bead sits against this multi-board right here. As you can see, it's a wee bit higher than the frame. It's just the way it's designed. This here multi-board is discoloured because my back was powder fell on my back and it has stuck to the oven and the oven was warm. I have cleaned it as best as I can for this video. This piece of glass is out of an ordinary house oven. It's just a high temperature glass. So there's a car. So these wee catches is for the, here you see here, to hold the door closed. Or just simple wee catches off the internet. This whole oven can be controlled from this one spot. Not only can I control the temperature and the time, the duration the oven's on for, I can turn the fan off if need be, but you have to be very careful there because if you turn the fan off when the heating element's on, there'll be a lot of heat sitting at the back of the oven. This light, I can also turn the lights off with this green button. The fan is currently going at the minute, right? So this here is sucking air in the middle and chucking it out, dispersing out the sides, top, bottom and sides. So this deflector plate at the back, as I talked about a minute ago, is curved to deflect the heat out, like a convection. That is a convection oven. Here at the top we have this heavy support. It's a guy, there's a runner for holding alloy wheels or anything really, but I can also click a grid in here. I haven't made the grid yet. The grid's an easy part. It just hangs on these 2 L channels here for hanging, say, multiple 100 items or whatever. The oven in width is 900mm wide, close to 900mm wide. I don't exactly know now, but it's close to it. It's about 700mm tall. And it's about 900mm deep back to base, so it's quite a big oven, and it's good. It's much more It's far better than an ordinary house oven anyway, which I currently use. This multi-board is bought out of an ordinary DIY store, so it's withstands temperatures up to, well, I say it withstands temperatures because it's been used in this oven, and it has stuck temperature. This oven's went up to 250 degrees and it's done no harm. There's no bits flaked off or nothing like that, jumped off onto my powder coat in the wheels, as you will see by the finish of the wheels at the end. These plates here, as I've mentioned, hold the multi-board to the actual insulation, so it keeps it from expanding and moving about, and it goes up the cold to warm and hot, you know, up the temperature and cooling down. It allows a wee bit of give and go, you know. So here we have a support just for this middle of the window frame. This window frame is a 75mm channel, aluminium channel, the same as the outside. It is not painted orange on the inside, it's just done with an etching primer, because if I was to paint orange past this point, the paint would boil and burn, as that wouldn't withstand that temperature. The paint I've used for this oven is a what do you call it? Vapormatic enamel paint, tractor paint. So I've used that from all my projects. You can see by the finish in that handle there now. I could have made these brackets square, but with all my projects I like to make things unique and different, and hence by looking at this oven you can see it's nice. So this door hangs on a hinge, a supporting system. So I'm behind this, or channel I mean. So I'm behind this these hinges. You have 3mm plate, and this 3mm plate is screwed to the oven itself, the whole internals. So I will walk through that in the manufacturing process. So I'm now going to go to the back of the oven. I think I've talked about everything in here. Oh yes, so see this, where this air has been sucked in here. Wait, watch this door here. The one's blowing the door. Okay, so when the air's been sucked in here through this wee grid design that I've made, this plate at the front, it sort of just it sucks air in and chucks air out at the top and bottom and sides, as I've mentioned. But this plate keeps a nice momentum, keeps the hot air in, makes the fan work even, if that makes sense. So if that plate wasn't there, the fan would be useless. The fan wouldn't. So at the minute, the plate, this vacuum plate, is close to the fan and close to the elements. So the fan has no other option but to suck in the middle and chuck the air out around the sides. So as you can see here, it's tarnished at this point. So there's two elements behind this plate, and you will see it in the manufacturing process and the pictures at the end. Also, this fan is the shaft. The fan is bought from a house oven or purchased online, but I have lengthened the shaft. That wasn't easy because it's welded in two places, and there's an inch 25mm 6mm bar set into the middle of it. And as anybody knows that works with metal, and metal tends to pull, especially when you're welding shafts, and especially something that small in two places. In one place it wouldn't have been as difficult, but because the shaft's welded in two places, it's very hard to get straight. And that was took 3 attempts to get that fan working. So that's everything talked about on the inside. I'm going to go to the outside now, so we'll close the door first. Oh yeah, so these wee catches here also keep the glass from falling. These catches are out of the house oven. See here, these ones is manufactured by me. When I put this door around here, these ones is manufactured by me, these 4. They're countersunk screws to keep the glass from falling down. Obviously the glass is not going to jump up, but they're there anyway. So this these clamps here hold the glass to the 75mm aluminium. Okay, so I'm going to go around the back of the oven now and just close this up, keep the wind from blowing it round and wrecking it. So the control panel is held on with 6 screws, 1, 2, 3, 4, 5, 6, 2 at the side and 1 top and bottom. The control panel is built out of stainless, and it is powder coated in black and orange flake. The back of the oven here, you can see where the fan is situated. So in behind here we have the house fan. There's a grid here just to allow, this fan's not actually sucking air in here, but it's just to allow the fan to cool down and breathe, because there's actually a wee cooling fan at the back of the main fan, if that makes sense. Okay, so in behind this panel, all these panels, you have insulation. You have insulation board, and you also have insulation, what do you call it, rock wool. and it withstands, it holds the temperature in very well, you know. It's the oven, when the oven's built up to temperature, it stays at temperature with, you know, it doesn't take that much to keep it up to temperature, and you'll see in the demonstration later. So I'm now going to take the oven back in the shade. No, I'm not actually, hold on. So here we have the channels. We have a dolly and we have a channel. I forgot, I have to do a demonstration of this first before I take it on the shade. So we have a dolly wheel and we have a tracking system. And this dolly wheel is built using stainless steel again. It is designed to hold a wheel on its flat. These free bearings roll in this tracking system upside down. So this sits this way. So I'm now going to do, I can spin the wheel also in the booth or in the oven if need be. When I'm powder coating. Obviously I don't need to spin it in the oven because the oven's a convection oven. The hot air's evenly dispersed around the oven. So the road's quite busy now. So what I'm going to do now is I'm going to hook the wheel onto this dolly, and I'm going to put the tracking system between the oven and the booth. Okay, so we're going to put this camera on the stand. 2 seconds. Okay, so what I'm going to do now is I'm going to open the door. I'm going to first put the tracking system onto the oven, then I'm going to connect it onto the booth. The ground's a wee bit uneven. The tracking system in the oven and the booth exactly the same height, off the ground to the bottom of the tracking system. So if I open this up now, somebody walks up the road, they'll be thinking I'm mad. Right, really see this. So this is the tracking system. Let me see if I get this in the camera nice and clear. So the hooks are made, they're really precise and they fit onto the tracking system in the oven. The wind's blowing this door and I don't like the way the wind's blowing it. You know, because it's aluminium at the end of the day, I don't want it to crack the welds. It'll be grand. Right, okay. So this I forgot to mention, see this face of this oven? This face of this oven is also stainless steel. It is welded in inside, outside, tacked in the middle, and it's just a face for the door and the seal. The width between the face of this and the door is 10mm. The seal is about 12mm or 11mm, maybe. It's about 11mm. So there's only a wee squash. Doesn't require no thick seal, you know, to keep the heat temperature in the oven. Actually, if that seal wasn't on, the oven would still go up the temperature. But obviously it's going to escape through the 10mm gap. But we're going to go back to this tracking system. I'm getting carried away. So this tracking system clips on here. Very simple. So it's clipped on there now. I'm not touching it. So I'm now going to bring the camera up. And just give a wee quick. So as you can see, it's clipped on to the tracking system in the oven. There's no gap between the 25mm angle that the tracking system is made out of. That tracking system and all the hooks took 2 days to make, and I actually made it when the ice was on the ground. And okay, so the tracking system is also supported by a channel in the oven going to this orange frame. So any weight sitting here on the dolly won't pull the oven down. It won't sink even with the heat in the oven. So now this dolly, I'll slide the dolly on. So this dolly can hold anything, not just alloy wheels. I can hold gearboxes, housings, anything. So I slide this dolly in. So this dolly is now slided under the booth, okay. So it's hard to do this. The ground's on level, right? So let me see if I can do this without wrecking the camera. So as you can see there, that's a nice neat fit. That's unbelievable fit. So that now is the booth connected to the oven, the door open. So what you want to do when you're powder coating alloy wheel, you want to bring the oven up to temperature, put the tracking system on. You can see it takes about literally 3 seconds if I didn't have the camera in my hand. As you can see here, I've writ oven on the bottom of this. That's because this end of this tracking system is matched to the oven. They're much similar, they're exactly the same, but it just fits better, you know. I have it filed and handcrafted to fit each other, very neat. So at this end fits the booth, a tracking system, and you can see here that there's no gaps. Look, if I was to pull this down, look, there's no gaps. There's not even, they're touching, the angles are touching the whole way around. So what I do now, obviously when I'm using the booth, if you want to go back to the video from 2 weeks ago, I don't need to use the device that spins the items, because the motorized unit that spins the items, or this control panel in the booth, because I can spin the items with my hand, really, you know. Obviously not touching the alley, but when the alley's hanging here, I could spin this when I'm applying the powder. So it's really, really good. So when the alley's on this, I can run the alley into the oven. Really, really, really good. And if I need to, just say I need to spin the wheel in the oven, I can spin it in here too. You obviously don't want to spin it off the threads, which would be a stupid thing to do, because you'd ruin the oven. You have powder in the oven, you'd also ruin your workpiece. So when the wheel's on the oven, I slide the wheel. I'll just do a wee walk back here. So the booth now is connected to the oven. If you want to see videos of the booth, go back on my channel 2 weeks ago and you will find the booth. The booth's actually really good too. The booth's a recycling system for the powder. So the oven now and the oven and the booth are sitting plumb to each other, because I have designed these two systems to be built around each other. So this system here, it's all designed by me, and it's really, really, really unique and really, really effective. So I'm now going to put the alley on the tracking system, and I'm going to slide it from the booth to the oven to the booth, and so just give me a second here to put this camera down again. So what I have here now is an alley, but so I want to split it. Somewhere. What I usually do is I put the oven or the wheel in the oven or in the booth first. So we have this dolly system. Screw this off. So this dolly system split. Put this into the center of the wheel. Okay, so we have a problem already. This wheel, this was designed for my alley wheels off my big Honda Accord. So obviously, as you've seen there, it slid through the wheel, so I can't demonstrate that. Should have tested that before I done this, but I don't have any other alloys, you know. But I might get something else, something to hang on it here. Wait there till I find something. I'll get something. Hold on. Okay, everyone. So I have went and fixed this item. So we now have the piece that I originally cut off for this reducer. What I can do here is I can put this on top of it, and I can now hang the wheel on this part for bigger wheels with bigger centers. I forgot to mention that this here wee thing was designed so that little surface area was touching the alley, so you apply as much powder to the wheel as possible. So that makes sense. With this one now, I can place it into the other wheels, such as this wheel here that didn't fit, that I only found out there now. So if I get this alley now, this alley is an 18-inch alley. This oven is designed to powder coat alloys up to 21-inch. So what I can do now is I can place this reducer, which I found in the garage, I never knew I had it. I can put this one inside the other one, and I can now hang the alley. How do I get this? I can now hang the alley like this in the tracking system. So what I'm going to do now is I'm going to put it in the oven and do a wee quick demonstration. So alley on the dolly and on the tracking system in the oven. What you want to do before you start powder coating is level the wheel up. So when the wheel's on the tracking system in the oven, put the jointer, or whatever you want to call it, the linkage, from the oven to the booth. And what I do now, for demonstration purposes, you'd obviously start with you bring the temperature of the wheel up to degas it, and they also apply the powder, bring it up to, I don't know, 90 degrees, 100 degrees. or bring it up to 180, let it fall to 100 degrees. So what I'm going to do now is do a demonstration, bring the camera back into my hand and do a demonstration of the actual alley from the tracking system. I just really watch my door. I don't want the one's very strong. Okay, so the alley now is in the booth, so I can apply, obviously the ground's not level here, I'm sitting on grass, but if I was in my garage, it's outside for daylight purposes of this video, but if I was to have this system, both of these units in the garage, this is all plumb and sits nice and even. So what I do now is I apply the powder here and I can spin the alley and apply the powder the whole way around. I can also apply the powder up to the bottom of the alley. Once the alley is chemical stripped and blasted, which I've done to my alleys on my big cars, I will show in the very end of this video. So now, as you can see, the tracking system runs through the joint. It doesn't even know the joint's there. Runs through under the oven, over the other joint, a wee knock, a wee jump there, but that's just because it's sitting up a wee bit. Okay, so the alley now is in the oven. What I can do now here is I'm going to set the camera down again. It's really awkward. What I can do now again is I can take the linkage off and I can close the door immediately, really fast. So now that the alley's in the oven sitting in the tracking system, the powder's been cured, and I can then turn side to the oven, or not side to the oven, but I can direct the oven, push the buttons in the oven to release the hold time or to reset to 10 minutes. Obviously with an alley wheel I always cure them to 20 minutes because they're so dense, as I've mentioned earlier on. So what I'm going to do now again is I'm going to take this whole system into the garage and I'm going to do a demonstration of it going up to temperature. Before that, I'm going to put the tracking system back on and bring the wheel out. So what I'm demonstrating here now is, say, the wheel cured. If the wheel's cured, I don't need to touch the alley. What I do, very, very fast, put the tracking system back on. Put the tracking system back on, no messing about, it's on. So I'd use a hot bit of metal, I would run the alley from the oven to the booth. And I'm going to put the camera in the oven now, without it melting it. It's only sitting at 20 degrees, so it's okay. So the oven's now the wheel's now in the booth. What I do now is I take this apart again, and the ground's not level, so I take the tracking system away. We've actually got brackets on the ground. Okay, so I take the tracking system away, and what I do then is when this oven's cooling down period, really, really, really good design. I close the door, keep dust and stuff falling on the alley. That's why my alleys is sitting in such good condition. There's no dust and stuff and dirt in them because I'm using such a clean process. So what I do then is very simple, is I close the oven door and temperature is obviously kept back in. Very simple, that's it closed. So as you can see, the tracking system is very, very fast. I don't need to touch the alley or any powder at all. Obviously the dolly on the, let me lower this door down again. Obviously the dolly on the hanging on the tracking system at the minute will be hot. Here at this point, it's obviously not hot at the minute, but so that's the tracking system. I'm going to take this apart here, right there. So that's the tracking system. Oh, so when the wheels cool down, I split this device again, and you have these pieces. Never realised that I had an extra component until now, but this actually worked very well. I need to clean it up and take the sharp edges off it. As I've mentioned, this used to be one reducer. The reason I wouldn't use this on a smaller wheel is because, well, maybe I shouldn't have cut it, to be honest, but it's not hard to fix. I can weld it back on. But the smaller reducer here, I meant that wasn't hitting the areas in the alley that I didn't want it to hit, the seat. Usually when alloy wheels is hung, they're hung by the valve and they hang them vertically, but I hang the alloy horizontal and you get a much better, I think you do anyway, you get a much better finish to the face because the powder falls in. So that's that. I hope you enjoyed. Wee bit of traffic, but nothing much. So I'm going to get a chair here now and just give it a wee stand on top to show the top of it outside before I go any further. Right there. So the oven, as I've mentioned, is really effective. That's the top, the back of the oven. You can see it's the same finish right round. Really neat. The vinyl. That vinyl was actually put on Christmas Day. That's how much of a boring life I have. And then I go to the top. So this is the top of the oven at the front, if that makes sense. So I think I've covered everything. As I've mentioned, I'm not here to talk about the buff, the powder coating buff, but it's in this video. If you want to see it in more detail, go to the video before this one. What I'm going to do now is I'm going to take this unit into the garage and I'm going to walk it through its, or take it through its temperature range. I'm going to take it from, it's currently sitting at 20 degrees because I have it set at 20 degrees. But I'm going to take it up to 200. I'll take it to 200. I mentioned 220, but I'll take it to 200 because it'll take a wee bit longer to get it to 220. As I mentioned, when I take this oven up to temperature as such as 200, it's harder to get it to 200 than it is to keep it at temperature. So when it's up at 200, it's very easy to keep it at temperature because of so thick. There's insulation's 3 inches thick here. There's an insulation board and there's also insulation rockwool packed in behind them blue covers. So the oven is now going to be transported into the garage. So as you can see here, there's a 3-inch gap between the booth and the oven when you're going to transfer items over from the booth to the oven, so the door doesn't hit the booth. Again, this handle is made out of wee bends and that's welded together, and I have them all burnished up, and you can see there's no weld showing or nothing like that. That handle, you know, if I was to make an ordinary handle for that, it probably would have took maybe 20 times shorter, 10 anyway. So say if it took me a day, or maybe a day to make a handle, it probably did. I could have made that handle in an hour if I was going to make it rough, but with all my projects I go overboard. Forgot to mention them behind this hinging mechanism. So when this door's open, there's no sag or no drop because it's so strong. That door's actually quite heavy. It's full of, there's a 2mm plate at the front. There's an insulation board, another insulation board. There's a bit of ply, 12mm ply timber inside. It's put together in a very unique way. So the 12mm bit of timber is used as packer plate to bring the 2 insulation boards out to the actual channel itself. And that's it. So I'm going to take it in the garage now and do a wee quick demonstration of it working. Let me go back here. So there's the front of the oven. That's nice. It's really fancy too, isn't it? You can see the booth in it in the mirror. Okay everyone, so I have the oven back in the garage. It was such a struggle to bring that oven in and out. The reason I took it out there is for the daylight, obviously, to show the quality of the components that I bought. That carpet was used because that ground's quite rough. I never mentioned in the video that the casters on this oven are 50mm. The same casters that are on the booth. So the oven's weighs between 200 kilograms and 250 kilograms. It's close to 7 foot tall. Right up here, look. So you see, it's close to 7 foot tall, the tallest point. I never mentioned here that this car sitting here has alloys that I have powder coated in the oven. This car, the wheels are really, really good, but they're currently covered in dirt. Okay, so what I'm going to do now is I'm going to set this temperature. This temperature is currently sitting at 10 degrees, but it's warmer outside. You see, that's why the oven's sitting up near 20. So what I'm going to do now is I'm going to raise this to, I will raise it to 180 degrees. No, actually, sorry, I'll take it to 200. So what I'm doing here now is I'm setting the temperature, but the oven's currently off because you can see here at the top, the counter's not counting down. So what I'm going to do is I'm going to keep raising this to 200. I'll take it to 200. I'll take it to 200 degrees. So what this oven's going to do now, as soon as I set this, when you see the light coming on here, look, this will be, I think it's a green light. The oven will start, it won't go up to temperature yet. What do you see? So it should come on there now. So the heating elements are both on. They are both controlled off this digital stat. This digital stat controls a relay. The relay is a solid state relay because of the high current. 25 amps. I think it's around 22 amps, 25 amps. So the reason the solid state's there is because there's no contact points that can melt like an ordinary relay. So as I've mentioned before, there's a light here, the lights. We also have the fan. You don't want to turn the fan off when the heating element is going, because you're clearly just, doesn't make sense. You're going to burn or heat the back of the oven up to a really high temperature. But I have put the fan switch there anyway for at the end. So say the fan is still going at the end, it stays on for 30. It's not 30 seconds, it's about 4 minutes the fan stays on at the end, or maybe more, depending on that delay timer I have on here. So this delay timer holds the fan on after the oven has done its cycle. So now what I want to do is set the time. So, what do you see? So what I do now is I put the hold button in. So the hold button stops the clock from counting down, and I also reset the clock. So when I push this button, the clock will set to 600 seconds. So it's really, really good. So this oven now is going up the temperature. I can actually hear it, the fan and the lights. You can hear the fan dialing down, and you can also hear see the lights dimming down, so you know what the two heating elements is on at the back. That's about it. So this oven now is going up the temperature. You can see it was at 31, it's now at 41. I'm going to set the camera down, and if you want to skip forward this part, you can. But I'm going to take it right up to temperature because I think I should demonstrate it. I think I should demonstrate the stat, knocking off and on the heating elements. I should demonstrate it holding the temperature, how well it holds the temperature. So I'm going to set the camera down, and once it gets to 10 minutes, I'm going to, or once it gets to 200 degrees, I'm going to press release the hold. Or I might release the hold now for demonstration purposes, because if I run this too long, it's going to be a long video. There's a lot on it. So if I release the hold button here now, let me see if I bring this close. If I release the hold, the timer starts counting down. Once this timer counts down, the heating elements shut down. Even though this light comes on green, this here has broken the contact going to the relays. The relay that controls the heating elements. So if you see this green light on after the 10 minutes, the heating elements are still off. If this is sitting at 4 nines, 4 nines means that this is disengaged, this timer. So what it's doing now, it's at 62 degrees. It's a convection oven. The air has been circulated around, so the air at the front of the oven is nearly as hot as at the back, but not exactly the same, obviously, because the heating elements are at the back. Inside the oven at the back, as you will see in the design, I have a big heating element. I think it's about 250 mil, and then I have one a wee bit smaller, and inside it's about 200 mil. So the two of them sit nice inside each other. The oven's now nearly at 70 degrees. When this oven goes to 90 or 9999, the fans at the back stay on and allow the temperature to recirculate around the oven for 4 minutes. I think I would set it 4 minutes, but I can up that or decrease that. And do you know something? I think it's actually perfect. It stays on for 4 minutes to allow the hot air, just not to fall in one place, but it allows the hot air to recirculate. Sometimes when I have the powder coating's cured, I open this door and keep like a wee gap like this when the oven stopped to allow the hot air to escape. But for the meantime, I'm going to demonstrate this now falling to zero. So there's not much else I can talk about. You can skip forward if you want, but I will be here until the end of this demonstration. I'm going to get a temperature probe gun too and probe the oven for proof, other than just showing my alloy wheels powder coated. So there's no point in me saying it's warm and you just can't feel the temperature, so I'm going to get this infrared gun. If I go this way maybe. So the oven now is currently at 88 degrees. You can see there in the bottom dial, the timer has just fallen to 400 seconds, which is how long? Halfway time, so it's between nearly that's 5 minutes point. 300 seconds. This is the gun. I will be demonstrating the temperature of the oven itself. I will open the oven and I will probe the oven with this infrared gun and show the operating temperature, or the current temperature. So if need be now, the powder in the oven was not already started to cure. Obviously the oven's going to be up to temperature, okay, but just say that the curing time wasn't met yet, so the initial point, I would hold the time like so. But for this demonstration, I'm going to let it fall right down to zero. At the end of this cycle, the oven will start beeping to tell me that it has finished its cycle with this beeper. This beeper is 12 volts DC. If you want to go through the manufacturing process of the electrical circuit, the wiring, I think I'll include wiring diagrams. All that will be included at the end of the video. But it's going to be very long, so please be aware. This mirror finished, the cover was only took off that today. The oven was finished 3 months ago. I took the cover off just for this video. You can see it's really nice. Over the top as usual, but what else is for it? So we're now at halfway point, we're 280 seconds. The oven is sitting at 111 degrees. Bear in mind that this oven is 4 times bigger than a house oven inside. 4 times? No, it's probably more, nearly 6 times bigger than a house oven inside. So it's getting up to temperature quite well. As I say, when it's at its temperature, it's really, it holds the temperature well. Now at 115, 117. Starts moving quite fast now, I think. So it took 10 minutes, nearly 10 minutes to get it to operating temperature. It has a bit to go yet, right enough. But for this video we're going to do, I'm not even going to take it to 200 degrees because it's too long. So I'm going to show the oven shutting down with the beeper going and the fan staying going and the heating elements off. 200 seconds. And the top dial, temperature at the bottom, 125 degrees. I always knew it was going to be a long video because there's so much work in it, demonstrating it. I could have made, 50 videos out of making this one system, but as I've mentioned in my introduction video, there's so much time involved in making these videos, and my projects are unique and there's a lot of work in them. For example, this handle took probably, it was a day I mentioned, a day to a wee bit over a day to weld it, cut it, weld it, polish it, sand it, file it. So these welds is not just sanded, they're filed, flat edge, there's no dips in the handle himself. These brackets could have been made square, but I decided to make them in a round cloud effect for fanciness. The two of them is identical, but mirror image of each other. So we're now at 119 seconds. Although oven shut down and the oven is at 136 degrees. So that's a much clearer. The camera's very low to the ground there, but if I stand here, hold this until it shuts down. I'll do a wee walk right. So there's the mirror and there's the outside. There's the inside the oven. All these joints, as I mentioned outside, are mitered and welded with aluminium. They are sanded flat. There's no feathers in them. It's just pure aluminium. As I mentioned there, these two brackets is on the handle is a mirror image of each other. We drew a line down the center here. At this point. I hope I haven't missed nothing, but I don't think I have. So inside the oven now is currently at 145 degrees. I haven't instructed it to go to 200. It will take another 5 minutes to bring it up to that temperature. You can see it's gone up quite fast, like it's not that bad. So it's now at 40 seconds left. The oven was incredible doing the alloy wheels in the car. The last images in this video will show the quality of the alloys. There's no dirt in them. They are done better than professional. Not to bomb or nothing, but there's no dirt in them. There's no blemishes in them. There's no orange peel in them. They are perfect, and it's all down to this equipment that I have used to do the alloys. Obviously I've done one at a time. So this oven's shutting down in 3 seconds. 1 second. So there we go. So you can hear the contacts inside the timer switch, and it breaks the power, the output from this relay. So this output's on now, telling it it's 155 degrees. This output's on, but it's not, the signal can't get through because the timer has it broken. Timer has the signal broke from the stat. The beeper is to tell me if I was in the house, if I walked away from the oven is finished. If I want, go out and open the door, leave the door on the latch to let the hot air out. So what I'm going to do now is I'm going to probe the oven. I'm going to probe the inside of the oven before the hot air escapes. So if I go to the back of the oven, so it's saying 112, but it's actually much warmer than that. So if I go up to the stat here, they're 180, 150 degrees. Let me see. There, 190 around the stack. Obviously hot air rises, so it's much warmer at the top of the oven. It's 150 degrees up here. When I take this camera off the stand, just really watch it doesn't melt. You see the good thing about it, that multi-board, that doesn't hold as much heat as steel would. So that's why I've used multi-board here. So if I go up to the top of the oven now and hold the light on, it's very warm. I watch the camera, it's 150 degrees. And this is telling me 150 degrees here. So it is roughly right, like, and obviously the size of the door, like the door's massive and all the hot air is now escaped. Even though I was to close this door again, I want to demonstrate it. So I should just actually let it run down, because you can see that the fan's still going at the back. That's to keep the hot air circulating, as I've mentioned. So I'm just going to let it shut down. So it's dropping to 147. It's actually a lot cooler not in there now, but you see how the probe holds the temperature. So we're going to let it run now until the fan cuts off. So the beeper is there to tell me, as I've mentioned. Obviously you don't want to pause it, because if you pause it, it means it's, you know, it's not doing its proper job. So if I paused it walking in the house by mistake, or even it was annoying me, the beeper, it means that the oven, the wheel's still in the oven, and you just want it to be a distraction so you can go out and just shut the whole thing down itself. Because when this oven shuts down, because of the design of this timer, it can start up again in 9,999 seconds, which is probably a week. This oven could start up in a week again if you left it on, because of the design of this timer at the top. So that's the reason I have the beeper on it, tell me that the oven is lying on. So the way I have it all wired and set up to work, the best I could do is a week delay before the oven starts again. So as you can see, I can go onto these buttons here and I can set the to be greater than 10 seconds. Let me see if I can know how to do it. I'll not touch it actually till the oven shuts down. So the oven probably has about 2 minutes left before it stops, and then that is the end of this video. I hope you enjoyed it. A lot of work involved in building this. For example, that door is it's designed to be, you know, so these panels wasn't held with rivets or nothing. You know, it's packed out. There's much like an ice cream wafer. There's so many layers in it. There's a layer of multi-board. There's a layer of insulation, and then there's a packer plate, which is wood, packer wood even, and plyboard. They slide together. 2 C shapes. They slide in here. Then this frame is welded. This frame then is welded around the 4 layers, 5 layers. 1, 2, 3, 4, 5 layers. You can see here the oven's drying off. A bit of water, just because it wasn't turned on in a long time. So the oven's going to stop now soon. The heating elements are not on. The stats telling them that they need to go on. They need to be turned on because the oven's still not up at the temperature, 200 degrees. But this timer is holding the circuit open, so the oven will not, the heating elements will not start. The 2 heating elements are wired in parallel to the solid state relay. These beads, I forgot to mention in the earlier on video, these beads is held with these special curved barbed pieces of plate, and they are fitted into wee holes. The beads is actually warm. See the wee holes here, look? A wee bit of holes, so they're not glued on there, and they're all done properly. So you can see here, I can pull it out. So literally 1 minute or less, I think. As you can see here, sorry, I says 4 minutes. It's been 9, take away 3. The oven's been now sitting on for 6 minutes since it stopped. So cooling down period 6 minutes. Nearly there. 8 minutes. Nearly 8 minutes. So as you can see, the door there is held open right up at 180 degrees. It's out of the way of any obstacles going into the oven. I could also hang gearboxes, anything off here. I'm not sure about the head of a car, but anything, because you don't want to. Well, you could put the head of the car in if you wanted to apply a bit of heat to it. If you're removing the valve gauge or anything like that, you could take it up to 250 degrees. Obviously, I don't want to be putting the oil in the oven bit, so it's just basically for powder coating. So the oven now is currently on 9 take away 2, so it's nearly 8 minutes. I didn't think the delay was on this long, but it obviously is. There, so it's shut down. The oven is now shut down. The fan is off. The heating elements are off. The stat is telling the heating elements to turn on, but the clock timer won't let the heating elements turn on because the circuit's broken. So you can see it's 1. So 8 minutes. The oven stays on. The fan cycle stays on. The beeping noise now is to tell me go out and turn the oven off, because if I don't turn the oven off, when this falls to 0, this cycle, the oven will start again and do its 10 minutes again. So if there was a wheel lying on there for a week and it cured, the oven would start up again with the wheel in the oven. But obviously you're not going to leave the wheel in the oven for a week. So the beeping noise here is to tell me that the oven's still on, and if the oven is still on, basically what I do is I go out. Camera's a bit blurry here. Why? Okay, there's back to normal. So when I go, basically what I do is shut the oven off, the isolator, or I can go over to the wall and turn it off here. So we have a 32 amp supply going for a 4mm cable, flex, tri-rated cable. I think that cable is actually used for caravans, charging socket. Or no, it's not charging socket, it's actually a supply for the caravans. That's 4mm flex. That's the only thing I never talked about at the minute here. So that's it. The demonstration finished at the oven. I hope you enjoyed it. You can see up in the under up there, the wee light seals. Them were purchased off online. The brackets, if you want to see all the building process of all them brackets, everything, the guide, there's so much work involved in it. Obviously stainless steel, very difficult to work with compared to most metals, all metals I'd say. And it pulls and it moves and you're welding it, heat applied to it, it pulls a lot. Aluminium's not as bad, but stainless is hard to work with. And I built everything in stainless because of its properties, corrosion resistant and all that. So that's it. Final wee demonstration of it. So that's it. So thank you for watching, everybody. I hope you enjoyed the video. If you want to see the manufacturing process now, stay. If you don't, go. There's 1,000 photos. A lot of work. You'll see where this oven all started. Started from an actual, wasn't meant to be so good, but it turned out very good. That's it. So thank you for watching, everybody. Enjoy the manufacturing process. You will see the much work involved in building something like this to this standard. Thank you for watching again. Okay everyone, so this is going to be a long process. So this project started off as something that wasn't going to be such a good project. It started off as a wooden crate. I used a multi-board which can be bought in your local DIY against a sheet of fibre insulation board. As you can see there, it is all tucked in nice and neat, ready for the front face. The stainless steel flanges. This oven was meant to be a temporary thing just to fix the wheels in my car, but I decided to go overboard as time went on. So this is the flanges, or the front face of the oven being tacked together and cut. This is also the point where the oven went from a temporary oven to a professional oven. As you can see, the wooden box, the crates, has been done away with. So these wooden boxes were some sort of crates, or some sort of crates. I don't know if they're for, I don't know. They're strong anyway, and there's rivets in them, so they can't pull or shrink and stuff. And I've also supported these wooden crates on the inside of the oven to the frame at the bottom. This will come later. So during this process, I realized that I couldn't get a fan to go through the 3-inch insulation at the back wall, so I had to lengthen the shaft on a standard cooker fan, convection fan. As you can see, I needed to place about a 6mm shaft into the middle of the screw and the motor end. This was welded together with a TIG. It needed to be done in such a way that it didn't pull. There was 3 attempts at this to get it right. If it wasn't right, the motor itself wouldn't work because of the imbalance. This is the first attempt it didn't work, and I can assure you that I was being very precise tacking this together, but the slightest offset caused disturbance, and it basically didn't, the vibration caused it to slow down too much. So then this is a second attempt using a V-block. This also didn't work, and then there was a third attempt which did work. So this was quite tricky. So this is the oven now placed on top of the stand with the 2 heating elements and the fan attached. After that, the back deflector plate. So this was the first attempt at the back deflector plate, but this was too light. So the second attempt of this back plate was increased to 2mm stainless. You will see this later. As to deflect the heat out and radius curves at the top and bottom, keeping it from discarding that multi-board. As you can see here, we're a wee bit ahead of ourselves. The tracking system is all done. So I done the oven in different stages, and as time went on, there was a lot to it. That guide at the tops, they hold hangers for mesh, or you can slide a sheet of mesh in to hold hundreds of items if need be on hooks. So this is me folding the new back plate. You can see here I'm not using a press, I'm slicing the stainless, which is 2mm, and I am folding it with my hands, and that's probably why I have sore hands today. This was done on the top and bottom, as you can see, and it's slid in nice and tight to the inside of the oven. This is one side done. This is the 2 sides folded up, ready for the holes to be bored, to be attached to the oven. This is mirror polished stainless. I decided to use mirrors because it's all I had. It was for another project, so I just used it to get rid of it. It's probably too good for the job, but this is the first attempt that it's been slid in. So the folds and the bends all needed to be calculated to fit a nice neat fit. These are the sections needed cut out for the light, the 2 lights, the light enclosures, the surrounds. Again, this is cut with the grinder, and then the carbide burr die grinder used to tidy up the holes, or the radius. You can see at this stage I have the holes bored for the heating elements and the back plate. This is the back deflector. Again, the back plate bolts onto this and right through the oven. So at this stage, the back plate is finished. This back deflector is finished, ready for the back plate. You can see the holes for the heating elements, top and bottom. This is 2 more side plates to deflect the heat away from the multi-board. experimenting, I could see that the heat was discolored in the multi-board, so it was a wee bit hot at the back. But it works perfect now. This is all upgraded to 2mm. This is me removing, the first time removing the protective coating for the, what do you call them? The rings, or the heating elements, and the fan. The lights at this stage is also attached. 3 screws at the bottom and 3 screws at the top, and then the 4 bolts pulls the back deflector plate to the oven itself. Here we have the elements bolted and the fan placed on, and the wee nut on it. So this is the back plate now, the plate that sits towards the face of the fan. This works with the fan to create suction, so if this plate wasn't there, the fan would suck. There'd be disturbance. So these wee marks was all marked out using a permanent marker, and then all the holes were bored on them. If you had a laser machine here, it would have been far faster. But I had to cut all these out with hand, and they're all filed into nice neat wee slots. This took a long time. I'd say close to... Right, this is 2mm plate, so I think it took me... Oh sorry, this is 3mm plate. This took me about a day, I think, to do all this. This plate that you're looking at here. And then the plate then was cut out, and no, I'm telling lies. The plate that's cut out is 2mm, and it's spot welded to a 3mm plate. It's just to save cutting the 3mm plate, that same holes in the 3mm plate. So the 2mm plate is spot welded to the 3mm plate. So basically it's 5mm thick at the spot welds. These pins, these bracket sort of type idea, or clamps, is they hold the back plate to the oven, so they go completely through the back deflector. There's laying 4 spacers that slide onto them to keep the back plate at an equal distance at the 4 positions away from the back deflector. Then the elements sit in between this gap and the fan. These is the wee clamps finished, and there's the 4 spacers. The wee holes is just for to keep them from turning when you tighten them, so they are screwed directly into the oven, the wood. This is the old back plate that is obviously done away with now. That's just a wee demo of the first time the fan was turned on, before the door was made. So the interior light brackets, as you've seen them at the start here, these images. These is to hold the glass that protects the bulb or for the lights. They are tucked up into the top right corner and the top left corner. They are they're identical, only the brushes is on one side, so they're basically a mirror replica of each other. These are filed out to fit the glass covers that are sitting there. You can see the amount of hand tools I'm using to create all these wee parts. The die grinder is used before the file. Take off to be more aggressive. The files for finer work. This is the first time they are attached. The multi-board was filed out and the holes were bored to hold these stainless plates to the oven itself. So this hole saw is obviously too small at this point, so the multi-board then is filed out using the die grinder with a carbide burr. This is it finished, more or less, ready for a heat shield or a tinfoil background. This is me welding nuts on to hold the wee glass bowls or the glass shields for the bulbs. So basically there's an M6 domed nut or bolt and nut used to fix the glass bowl in place, just to hold it. So this is it finished, ready to be screwed on. There's so many images of the building process of this oven. So again now, this is me building the refractor plate. So this is basically just to reflect the light out the back. So it's a bit of tinfoil doubled over. I think it's doubled over a couple of times, maybe 3 or 4 times. And it's used, so I shape it into a nice wee curve just using the glass faces for the bowls. Then I put a hole in it. And this is basically to reflect the light out for the oven itself. So if these weren't there, the bulbs would probably also burn the insulation. So, or heat it up anyway. So this is, obviously I needed 2 of them because there's 2 lights in the oven. And they were cut nice and neat then, and then placed into the holes that I bored with the hole saw and filed out. So it was a wee bit of work. So if I was to place the bulb in there now, there'd be less light reflected out. So basically it's just a reflector at the end of the day. That also keeps the heat away from the insulation, heat of the bulb. The bulbs are 40 watt each. So these bulbs is E14 bulbs. This is the lamp holder, ceramic lamp holders that are fixed to the oven at the rear end of it. There's 2 of everything, for 1 for each side. So this is it finished, the plate that holds the glass bowl that protects the bulb, and they are fitted in position here. So the door, manufacturing the door was a very lengthy process. So I decided to build it out of 75mm channel angle, and it is all cut using the grinder and the thin disc. 1mm disc, 4.5 inch grinder, and there was one length, 21 feet, 25 feet. This is the middle area of the door. So this is made to be the same size as a glass out of a house oven, with a 5mm edge. So basically that black rim runs around the border of that glass. I want it as big as possible so you can see in. This is the door being built. It's quite unique. So the multi-board, and then you have an insulation board at 25mm, and then you have another insulation board at 25mm, and then you have 2 bits of timber in the middle, which is packers, and also the bit of mirror stainless that you've seen in the video demonstrations. And this all added up to the same size as the inside of the channel. This is me cutting the mirror polished stainless that I had left over off one of my projects. I was looking about for something to use for the face of the door, and I didn't have nothing apart from this, so I decided to go ahead and use it because it was going to get destroyed anyway lying about. So this bit of copper is used to cut the protective coating on the stainless. Obviously copper is much softer, so it doesn't affect the stainless, the mirror finish, or to stop scratches. So a straight edge is used to track the stainless before fully cutting through it. I just keep the edge as straight as possible with the grinder. Again, it's a thin cutting disc. This is the door with all the layers except the stainless sheet. So this is cut at the exact same size as the other layers, such as the inner board, the packer board, and the insulation boards, and the multi-board. Then the channel for the inner window was placed on the inside. However, it is hard to place they all in there together, so the top channel had to be cut in two to get it in position. As you can see here, these joints is all cut with the grinder again, and they are marked out and filed to fit. No gaps, so this is the one was cut at the top to get them in, get it in position even. Without this cut, it is impossible to fit the four of them in the inner hole without cutting the boards, all the door, or the 4-5 sections. This cut then can be welded when the other joints are being welded. This is the door ready for the outer channels, the surround, the border. Same thing again, so these were going to be needed to be all mitered and welded. So this is the door close up. That you can see the packer in the middle that pushes the two insulation boards out towards the two sheets. This keeps the channel tight around the door when it is placed on it. As you can see here, the channels are sitting on by themselves and they don't fall off because of the packer. The wooden packers push all the insulation boards out evenly right round. This is the door ready for welding. Making sure that I don't damage the mirror polish sheet on the other side and the multi-board at this side. So this is the door been set aside, ready for welding. You can see the handle marks are already in place, the two black permanent lines. This is the nice mitered edges. There's 16 of them edges, nice and neat, cut with grinder. The hinges mechanism, or the plates, the bolts for the hinges are placed in behind the channel for more support, and rather than just placing nuts on it, nuts and bolts. So the insulation board and the multi-board were cut out and the plates set nice and neat against them. So they're never going to move out of position because they are held in these wee pockets that I have cut out. This is me pressing welding the aluminium frames together, so I'm just pushing it down with the cars on the lift. This is welded with a MIG welder because I currently don't have an aluminium TIG. They are sanded flush. They are V'd beforehand, a wee small V, just to keep away, just to make sure it's completely welded, not sitting on the top of the angle, well burnt in, you know. So there's 16 welds, including the weld in the middle of the door, to allow the two channel pieces to slide in for the window. So as you can see, it's MIG welding. It's a wee bit dirty, but it's all I had at that time. So this is me pushing the inner window out tight. The two pieces that need it welded together, out nice and even, level. This is the door all welded, ready for sanding at this stage. On the outside. Again, just MIG welding. Doesn't need to be neat. It's going to be sanded anyway. But quite tricky because I didn't want to burn the protective coating on the stainless. I also had to line everything up, and I also didn't want to mark the multi-board at the back here. So the wee plate with the two holes on it there is just to support the outer edge. It's not really required, but it helps. So today when the door has been blown open, sort of helps the hinging side of it and stops any weakening of the door support, or that main upright at that side. This is the door all sanded, nice and neat, ready for etching or etch primer. So basically that vinyl or that protective coating is kept on during painting. You can see using a dual action sander here or DA sander to get nice and neat joints. This is the door ready for painting, completely ready for painting, ready for taping up. Lots of photos of this project. There's so much building in it, manufacturing. This door took about maybe 4 days to get to where it is. Could have built a simpler door, but it's put together in a really good way, you know. The packer plates in the middle. So these wee brackets is to hold the glass, the high temperature glass for the window. It keeps the glass from dropping down. And there's also 2 brackets placed in the top. Also, just to match. And the 2 clamps at the side clamp the glass into the frame. The glass has no seal on it because it's such a tight gap. There's no gap between it at all. So you can see here the multi-board is nice and clean. When I powder coated in the wheels in the car, it left it all black because I had my back against the door, and the door was hot, and there was powder lying on my back on an old bodysuit. So these are the 4 plates used to space the both hinges out away from the door frame and the actual oven. They allow the oven door to open around 180 degrees. It also allows the doors to be even against the oven, equally spaced right round the outside border of the oven, or the stainless face. This is the 2 heavy plates that are placed inside the door. There's also 2 more of these plates placed inside the oven. So these is actually 5mm, 6mm thick. This is the oven, the hinging mechanism. So this is like the frame that sits up the side of the door and inside of the oven. It's made of 6mm plate and 40mm box iron. These holes are directly bolted or screwed into the wooden frame, and there's a rung of grip fill behind it. You will see it in position in a second. This is this upright, or this support in position. It screws directly into that timbered frame, and the timber frame is all tacked together, as you can see there. So them plates that are tapped out to M8 slide down the inside of the 40mm box. The hinge bolts on to this lane, and this is the grip fill surface that sits against the wood. There's about 8 screws that hold this. That fixes this to the wood, and it is then tacked down the stainless front face, as you can see here. It is really strong, so today when the wind was blowing around, this is a point that's not going to break. Obviously because it's welded and it's bolted or screwed in so many points with coarse screws and grip filled. Then I could proceed to boring the holes and lining up the door. So this is the aluminium frame that was currently all cut, prepped. So this was lined up to the door along with spacers. And the plates are sitting in behind here where the wee clamps are. So these holes was all pre-drilled. This is the holes drilled. But these holes then was changed to match the sill. So the sill in the door was 10mm. I think it's 10 or 12mm, 10 to 12mm. So these holes had to be slotted in to allow the door to slide out away from the face for the thickness of the sill. So these plates slide down the inside of the 40mm box, as I've previously mentioned. The hinge bolts directly to these plates. The plates are held in place with another wee plate sitting below. It's basically much stronger and much easier than trying to place nuts up the inside. So this is the holes elongated, so they're made into like an oval shape now to allow the door to travel out. I think there was already a 5mm gap in the door, but I needed an extra 5mm for the 10mm seal. So I moved the holes out 10mm, just to allow a wee bit of adjustment before I started putting the door on when it was finished. So this is the door, the frame all sitting on, bolted on. You can see the heavy plates on the inside, which will be later fixed inside the door. That's the door and all mounted at that point. Not welded at that stage. Just trying it on. Very strong. The door's quite heavy, so it's they have a strong hinging system that side. Or frame support. This is the rubber beads that I've been talking about. So basically, they have you cut them to size and you fit them on a wee 3mm hole, and the wee brackets there slide into the holes. Really good. Worked out really well. The seals are held into the bar plates with epoxy resin. So I forgot to mention that front face is screwed into the frame with about 50mm screws. These brackets is to support the catches at the other side of the door, so the opposite end of the hinging mechanism. Here at this point, so these is tapped to 5mm with 5mm bolts. They are screwed down just to support that front face. When you close the door with the catches or the latching mechanism. These is also grip filled on and screwed up and tight. These screws is actually 70mm long on the side. They're grip filled below them, and then the catches is screwed on them with wee countersunk screws or bolts. A lot of work involved, a lot of work. So basically, if the ME brackets that I placed in there weren't there, the front face would tend to spring out. So this control panel is another project of itself, but we'll go on that in a wee minute. So the handle itself, obviously it doesn't look like the handle that you see in the oven today, but it's welded up. 3 pieces, 2 bends and a straight bit of tube or pipe. It is 60mm diameter, I think, as far as I mind. It is welded on a flat, tacked up on a flat edge. Then it is grinded, then filed to remove any dips. Obviously, the grinder has left. After that, it is sanded using dual action or a rotary sander. And then it is sanded using finer gauge sandpaper. Then it is burnished using black soap, coarse soap, up through the grades. So this is the wee brackets I made for the handle. They're a unique shape. There's the wee cardboard stencil in the background. So they are shaped like a cloud rather than a square plate, just to make it different. There's 2 holes bored on them. One center hole that are welded from the back. Then there's 2 holes for the mounting points. So these holes here is obviously too small. They're roughly about 12mm, so they are reamed out to 16mm using a carbide burr. I don't know why I haven't used my die grinder at this point. Maybe it wasn't there, but they are reamed out to the exact same sizes as the bends. So the tube 16mm, and they are welded from the back. This was designed in a way so that I could polish it, len weld it, without tarnishing it too much. So this is the brackets being cut with the grinder. They're basically just cut straight edges, and they're shaped using carbide burr again, and files. The bits of tape there are to keep them from being marked because they're a mirror polished sheet. They are then countersunked. The holes is bored on them. There's a lot of work on this, a lot of organisation through the different stages. So I had to bore the holes in this before I was welding them, obviously, and all, and make sure they were in an immaculate finish before welding them on, because I wouldn't be able to get them off the polisher again. So these plates was polished before they were welded on, and then I run around them to get the nice cloud effect, as I call it, rather than just a nice square plate. They're sanded with dual action sander, 2-inch sander, and you have a nice neat plates. They're bolted together to make them identical. Obviously we need two. So these are bolted directly into the door frame. There's the nuts, I think they're 4mm. 4mm nuts is tacked to that stainless 2mm poly sheet. There's 4 holes in the sheet, and the 4 holes go directly through the frame, and the nuts are attached directly to that mirror poly sheet, as I've mentioned. This also helps support the door, you know, because it's the crisscross angle, diagonal. Keeps the door from sagging. Would help anyway. And obviously the door's welded, but every little helps. So this is lining up the handle to the door. This is polishing it before welding the cloud brackets on it. They're using a salsa wheel first, a coarse wheel, then black polish. Bring it up to a mirror-like finish. Then I'm using finer grades cloth type wheel then with green soap. This is Azibo again, he's in all the videos, some people might notice. So we're probably now about halfway into these photos, a wee bit over it. Some work involved in it. So again, this is polishing the brackets. Final finish of the mirror. It removes all the sharp edges too, and also the edges that I have run the dual action against. Plus is tacking the cloud brackets on and making sure they are identical. So if I draw a line through the handle, make sure they're a mirror-like finish. They're in the same position at each side. The bit of copper there is to attach the clamp for the welder to keep it from marking the mirror finish that I have polished. The tape's holding the copper on. So these brackets, as I mentioned here, are welded, or these plates is welded directly to the bends at the back. The colour that was the welder has left in them, I've left the colour in them for no reason. Just hard to get it out, but it's also it's cool looking. Seeing this colour and the other side against the burr. Just handles about, I forgot to mention, probably about 7 inches long. Point to point, or bend to bend, centre of each bend, 7 inches long. At this point it is ready to be welded. Or bolted, sorry. Bore the holes in the frame. So this is the holes bored right through in the mirror finish. And this is the bracket, or the handle finished. I think it's finished at that stage. It looks like it isn't finished at the top, so I think I'll give it a final polish. Yeah, I do. Yeah, you can see it's not finished at that stage. So this handle M was polished and completely on the outside, as you've seen in the videos earlier, video clips. So this is the frame, all welded up for the oven. It is welded up using, and it's built using 25mm box, my steel. So it's obviously a black scale on this. So what I like to do with all my steel is I like to remove the black scale using a sandblaster or cast beads. And I run H primer, a 2-pack primer, and then an enamel paint, tractor paint on it. But at this stage we are still welding here, using a MIG welder. This is sandblasting all the black scale off it. So obviously when you get my steel, there's wee bits of, you know, corrosion already on it, lying out in the rain and stuff, and I try to get the best of the best bunch, but it's hard to. So this is the oven with the frame primered, ready for painting, but we will go through that later. This is the support that holds any heavy obstacles hanging on the tracking system. So this bolts directly, there's a bolt runs from the tracking system right up into this frame. So at this point there's an M8 nut rivet attached to the frame at both sides for that hanger for the heavy items. So this is another project by itself. So this control panel is handcrafted too. sheet steel. First of all, I decided to build the front face and at an angle, so it's not sitting flush with the door, it's sitting at a wee angle off, facing the right hand side. So these wee nicks is for the top and bottom of the enclosure. So this is the top plate and the bottom plate to be folded. I was going to weld this completely, but I decided to spot weld it instead. So to spot weld it, I need 3 lips hanging down into the panel. These lips or flanges is roughly 10 to 15 mil. I think it's 10 to 15 mil long. This bit of plate's used to cut the stainless and then track it to allow folding, as I don't have a press brake. Again, this is the angle that I'm talking about, that the panel sits, the front face of the control panel sits off. I don't know if it's 30 degrees from the actual face of the door. So rather than having the control panel sitting at the same angle as the front face of the door, I decided to put it out in a wee angle. Just makes it stand out a bit more and it's easier to read, you know, rather than looking at it direct on. So again, this is the bottom plate now, I think, seems similar to the top. There's the top finish, so another one identical, more like finish, top bottom. So the folds is round the opposite direction this time. They are cut and tracked using the bits of stainless steel there, and they are folded up. Nearly finished at this stage, ready for welding. This is clamping the top and bottom faces on, ready for the spot welder. So here you can see I'm using a bit of polycarbonate to keep it clamped from marking the stainless, as it's going to be powder coated. At the start I wasn't going to powder coat this, but I changed my mind, as I do with a lot of stuff. So this is the box spot welded into position, the face, top and bottom. Rather than welding it right round, causes more distortion and stuff with too much heat in it, so I just decided to spot weld it. So this box holds all the components, the control circuitry for the oven. You'll see me cutting the holes out it now for the timer and the clock, or the clock timer and the stack, and the switches for the lights, the beeper and the fan. They're already all marked out at that point. So these are the 2 holes being bored for the switches. Started off at 6mm, multiple 5mm holes, and then they're reamed out using the Dremel or carbide burr. You got tungsten tip. It's really hard, like a diamond material. Carbide, and then so after this stage they are filed out to, I think the switches is, as far as I mind, I think they're near 16mm too. So you can see a wee notch in them there, that's just to allow the switch to slide in. So there's a top and bottom in the switch. A Dremel is used to cut out the holes for the 2 control units, the stat and the timer. These holes is then also filed using a flat file to allow the both control devices to slide in nice and neat. These devices are clamped from the back using the wee clamps that has come along with them. These devices is purchased online. One of them is coming from RS Components. So this enclosure was initially done white. I think I done it white because I was going to do it a candy colour over the top of it. But this didn't work out too well, I didn't like it, so I went away and I done it again. Spent a lot of messing about at this point, I shouldn't have, but I did. So this cover is white to be powder coated. I think it's a candy purple, so I put candy purple on it, but the powder was a wee bit, I think the powder was damp. There was an issue with the powder, so then I decided to use the red. But for some reason, I changed it from red again. I didn't like the red. Probably should have kept it red, you know, but I then dipped it, cleaned it again and done it black. And then bits of white. I don't know what that is, dust or something, but it should be on it. For the picture. That's what maybe washed. The water droplets or something. But at this stage then it is done black, and then I add a lacquer and gold orangey sparkle over it because I had the powder lying there and I just decided to do it. So this is the candy flake in the oven, the final time. So wiring off the oven was a long enough process too, getting it all working the way I wanted it to work. So I described it in the demonstration how it works. The fan is wired here directly into the other control box was removed and ended up and it was connected off used instead. So the solid state relay there is on the left. It's not like that now. So there's a lot of trial and error involved in this. This solid state relay now sits on a heat sink. This is the wires runs to the lights and everything else. The fan, the heating elements. The heating elements is 3.5mm squared cable run to them. This is the wee plate that's used for the stat, as you have seen in the videos demonstrations. This was initially at the top, but I then moved it at the side because I found it to be more effective. It worked better. This is the temperature probe itself. It sits into the wee plate that I have made. So as you can see here, this is the early stages when there's no tracking system built onto the oven. This is me reaming out the hole for the beeper. The two wee holes at the bottom is for the hold switch, just the latching switch, and a momentary switch. It's for the reset. So this is the oven all wired and complete. As I say, the solid state relay does not sit like that nowhere on a stainless plate. It sits on a heatsink. Because the one that was on there fried because there was no heatsink. There was too much of a load on it, and the stainless plate wasn't dissipating the heat enough. So I had to get an aluminium heatsink. I think I have pictures of this. You will see. So this is inside the isolator. So this is the main supply, and then the out supply going to the connector blocks for the heating elements. This is the plate that it holds the isolator. So this bolts directly to the frame, the orange frame on the oven. These holes is bored out to be 6mm, and the frame is tapped M6 holes for, I think it's cap bolts, stainless steel that could hold the isolator on. Tap and drill. This is the 4 holes for the isolator itself, not the holes that bolt the plate to the frame. So the exterior panels took place just before Christmas. So this sheet came damaged and I had to work around the damaged bits, as you can see here. It's a 10 by 5 foot sheet. I had it worked out to use the sheet, but I then had to make the bottom in 3 pieces because of the damage on the sheet. This sheet is 2mm aluminium grade. Very easy to work with compared to stainless. I am using straight edge and a grinder again. Messy, but you can also damage this sheet by standing on it. So that's what the timber edges is for there, to really stand on while I cut. So this is one of the sides complete. So first of all, before I have folded these sheets, I have cut all the panels to the correct size, allowing for all the folds at each side where they are required. They are tracked and folded up just on the bench there with nothing else, making sure not to cut through fully, otherwise they would have been destroyed. So this is the hole being cut out for the panel, the control panel. This is the holes being cut out for the hinges that the pointer shrunk screws bolt through. and again this is the two side panels placed on the oven. This is the door bolted, holding the panel on this right hand side, if you're looking from the back. Again we have the hinges bolted in place with the plates and all on. So these panels is bolted at this point, using wee bits of timber that are screwed directly to this wooden frame. This is used to pop the hole, punch the hole for the screw. A countersunk screw is placed in this. So this is the top packer. So much work involved in this. These packers are used to for the jointing area so the sheet doesn't sag. This is a control panel in place with this panel wired up and all. Looks very snazzy. This is the bottom sheet. Again, this could have been made in 2 panels, but it was made in 3 pieces because of the damage that had come on the sheet from the courier. So you can see here how neat it is. Everything lines up in the legs. There's no gaps enough, no serious gaps. It's all done down to the last quarter of a mil, if not less. This conduit, flexi conduit, had to be a hole placed in this for a gland that contains the flexi conduit. So these panels, as you can see, are aluminium. So rather than just letting them lie open to the atmosphere, I have sanded all of them on the inside and painted them with red oxide to keep them from corroding in the future. This will come later. This slot that you see here is to allow the stainless plate to slide up into it for the isolator. This is the 3 plates, the way they will be bolted underneath, 3 sheets, the way they will be bolted underneath, as you can see here. There's no gaps between these slots. There's probably less than a quarter of a mil, a lot less, probably they're touching exactly nearly. You can see this in the demonstrations earlier. So these wee brackets here is used to hold the surround around the fan. So this is a wee plate that was rolled to sit around the fan. It just keeps that insulation from hitting it. The wee cooling fan that's inside. So you can see these wee angle brackets held on here, bolted on here now. These are then directly screwed into the wooden frame of the oven. The wee brackets is tapped. I think they're M4 screws, dome screws. So again, this is the panel for the back. You can see a back rotor on it there. There needed to be a hole cut in this for the fan. There it is there. This is cut out using Dremel or grinder. I think it was a grinder. You need to be very careful not to slip onto the face of the sheet. It was then filed out to the right side. It's roughly about 4 inches. It's just to allow a wee bit of air. This mesh is glued on with epoxy. It's stainless mesh. It allows the air to float around. So there's just not trapped completely, closed off. This wee hole is to allow for the shaft of the motor, because this was hidden. This is why there was an S on top of it. There's the S there now, it's just to cover this hole. So basically that mesh is hitting the shaft of the motor when it was spinning, slowing it down, making a noise. So it's just I had an S shaped bit of stainless line, so I stuck it on. So I call it super oven now. Okay, so final touches. This is the sheets, all inside being coated with red oxide, just to keep contamination, corrosion of the aluminium taking place in the future. This was actually Christmas Day, Boxing Day even. They were coated on Christmas Day. They were painted on Boxing Day. This is Christmas Day now, and they're coated with a very snazzy looking blue vinyl. It's like a brushed. The colour is stands out a lot. It's like a neon blue. I don't know what way to describe it. This is the frame. It sits over the top of the oven. It takes the force of the actual weight of the wheels So this is everything been painted. The door, the frame, painted with a Kubota orange Refractor paint. It's a really good paint, and as I say in all my videos, I use it, and it's the finish is unbelievable. You'd think it was powder coating. If you put it on thick enough, if you put it on too thick, it runs. Obviously, like all paints, but if you get this paint right with the right temperature, you get a immaculate finish. The orange fill, etc. So this is the door and the frame been painted. Everything was already sanded at that point and primed. In the tent outside. So this is everything nearly finished and ready for assembly. So this is a up close photo of it painted, frame and door. The frame is held on there with screws, you can see, to keep it from coping off when I was painting. I think is there water in that door? It might have been given a wee polish. So all these sheets, or these outer panels, was as they were coated, any wee edges were glued behind the panel to keep them from lifting in the future. Then there are no nuts used, there are proper aluminium M4 rivets, nut rivets, for everything to bolt together. So this is the oven being winched up and placed onto the orange frame. Doesn't look like much at the minute, but it's really good. As the video clips showed earlier. It is now sitting in position. You can see the two wee edges of the frame sitting up into the oven. It is then coated on with a Rockwell insulation. So this oven now has an insulation of 25mm insulation on the inside. Then the wooden frame. Then this Rockwell, which is 50mm wide. You can see the black frame going up around there now, bolted. This supports the weight of anything hanging on the tracking system. The panels then are placed around the insulation. You can see that the hinges are held in place, or the nuts for the hinges are held in place with wee bars. This is the top covers being placed on, everything covered on fiberglass or Rockwell. So this is basically the final assembly of the oven. The bottom done, and then the last part was done was the back. Everything is tidied up, the wires, all cable tied together, nice and neat. At this stage, the solid state relay is still not on its aluminium base. This is done later. So the isolator and everything bolted on, ready for the panels underneath. The insulation all covered in around the whole back of the oven. So as I mentioned there, the door was in the tent. The door was given a wee final polish to leave it to the standard that I wanted. Not required, but just me again. It's just the way my head works. So this drain pipe here's for any steam to blow off if the oven was drying out. It's also allowed the oven to expand and retract when it's going through its different temperature stages. I don't even know. This is a tracking system, so this is a really good long process. I think it was quite cold here then. It might have been snowing, because as far as I mind, I thought it was snowing. So this tracking system was first built for the oven, and then it was built for the booth. It was all done in the same few days, but you know, I built it for the oven, the booth, then I made the part in the middle. It's all handcrafted using grinders,
files and stuff like that. Wee bits and bobs that I had lying, you know. So I didn't even think about the dolly or the pulley wheel at this stage. I just decided on how am I going to get these 25mm bars together, nice and neat in a unique way. So I didn't want no ugliness, no like harsh big brackets. So I made these be nice tubes and notched them all out and filed them out, 2 of them, to hold the 25mm bars that the dolly wheel runs along. The 2 of these needs to be identical, obviously. So they are cut out up high in the middle there to allow the dolly wheel to pass. I will demonstrate this here. So there's wee bits that need to be took off more than the other to allow the 25mm bar. So you can see the bearings there now. That's what I'm looking to show. The bearings need to run past that top height. It's really hard to explain what I'm trying to talk about here. I hope the video will demonstrate it. So the bearings need to pass the frame at the top in order for the wheel or any item to pass from the oven to the booth. So here I'm showing these items being cut out with another one even be cut out identical to the one that I have just done in the background. So this is the tracking system. It sits in the middle. No hooks were designed at this stage. These needed to be welded or tacked up then, but stainless tends to pull a lot, so I needed to be very careful not to do too much welding to this. You end up buckling things, and so it's just basically tacked up like this. If I was to weld that continuously, this angle irons would tend to bow, and I didn't want that. So obviously the weight's going to be held not really there at that point. The weight's going to be held at the 2 ends, the oven and the booth. So if I'm to hang an obstacle such as a 200 kg, I don't know, anything at that weight, which is not going to be hung there obviously, but if I did, the hooks is the end that's going to be holding the weight, not them 2 wee round brackets, or wee connectors. So this is the point where it is being made for the powder coating booth. So this is the tracking system for the powder coating booth or the oven, I'm not sure now, but it's tacked up using wee bits of angle iron and all cut out and neat and shaped and fit. So there's going to be 2 holes bored in this. They're going to be directly bolted to both the oven and the powder coating booth. So you can see here, actually I done the oven first. So this is the oven and the wee hooks are all attached, or TIG welded on. A lot of work on this. This took maybe 4 days and maybe more as far as I mind. Others, night time, out working at 10 o'clock at night. So these hooks then slide onto similar wee hooks on the oven. It's all done down to the last, I would say, 0.1 of a mil, easy, because there's no ridges or nothing to get when they're slid on each other, as you can see here. So these is the wee 2 hooks that the linkage tracking system will slide onto. 6mm cut, 6mm slot, I'd say. They're cut and then they're tapered off for neatness, and then I think I rounded them. Yeah, there. These are then TIG welded on too. I'm obviously slipping them on my glove because they're warm at that point. So this is the tacking off everything together, nice and neat. You can see there's no gaps between the 2 25mm angle irons at either side. The less of the gap, the better. Means the obstacles won't jump. So that's me. Don't know why I took that picture, but it's there anyway. So at this point, these hooks or catches or linkages, whatever you want to call them, they were welded up fully on the oven side, and the actual linkage or the pieces set in the middle to link the oven and the booth together. The next step was building the tracking system for the booth. this was very similar, but there was a difference on how to exactly bolt the tracking system to the powder coating booth itself. So this is me holding it out upright, and you can see how well that each piece fits each other, holds on. So any weight applied to the linkage in the middle will rest on them hooks. So that's why they are heavy and they're strong, and there's no play in them, obviously, to keep the same at the same height, the same level when the trolley wheel is passing over the top of the joint. So the next stage now is building the booth. Here you can see the two angle irons sitting ready, cut and all, ready for the supports that hold them together, as well as the brackets or the mounts that they are affixed to the booth, and also the hooks to be applied. So at this is done a wee bit different. So at this time the 30mm box is welded to the back end of the 25mm angle bar used as runners again. So this part here is for the front face of the booth. This wee cutout allows the bearings to pass underneath. You can see here now this is tacked on to the front face. It's filed, nice and neat shape. So it's obviously cut out with a grinder first, and then shaped up, tidied up using files, flat files and square files. So here we are just welding them on, tacking them on still. The back one is welded more than the front. You don't want to put too much welding on these, as you can distort the shape of them or the angle iron. So this is the back, welded fully here with the TIG welder, stainless steel. I'm not sure if I run the welds down the side. I think I do. A wee bit, there you go, so just a wee bit, not too much. Distort the box there in a wee bit. So this front face is just another support, another mounting point for the bolts and the spray booth. We know that the oven bolts directly up to the, what do you call it, the multi-board, or the heatproof board, or whatever you want to call it, bolts directly up into it. And the booth is different. There's two spacers set to bring the tracking system to the same height as the oven, to drop it down a wee bit from the control panel in the booth. The oven was built around the booth, so the oven was built second, the booth was built first, so the oven's height is built directly for the booth. This was all kept in mind at the very start when I started the oven back in September. The booth was built 5 years ago. This is another two hooks now, it's similar to the oven, welded directly onto the booth's tracking system. These are also welded up full. This ensures good strength when there's any weight hanging on the link in the middle, as I call it, the 1200mm or 1500mm link that I demonstrated in the video. So this is them hooks also welded up fully with a TIG welder. Again, the other side of it welded fully. The support at the top is only tacked, well, strong tacks. So this is the runner, the tracking system, as I call it, nearly finished. It's probably longer than, this probably is about maybe close to well, the bit in the middle is about 1500mm and the other two 600, so it is working at about 2.5 meters long, the whole thing. Could be maybe 2600 as far as I need to measure it, but I'm boring the holes at this stage for the oven and the booth. However, the booth has spacers to be tacked on to drop the tracking system to the right height of the oven. This is the building of the what do you call it, the pulley system, or the jockey wheel, I call it, the pulley system, runs across the track. So here you have a 12mm bolt, or M10 bolt tracked for a 2mm plate. 2mm plate slides in between it and is welded up fully, just for more strength. 3 bearings, 3 holes, 3 bolts, 6 nuts, 12 washers, all used, or no washers used at all actually. It doesn't bother using the washers at the end up. But these stainless bolts can be adjusted to fit the tracking system. The less play, the better. When the wheel or items been run along the track. Any item runs with ease at the minute. So these tracking systems you want to keep clean with no dirt and stuff in it. Also because the dirt would fall on top of the items you're powder coating. So they're easy kept clean anyway, because the one in the oven never gets no dirt. The oven's always shut. The booth can get powder on it, so you have to sometimes chemical dip the tracking system or the wheels to remove the powder. So this is it all finished, ready to be bolted into the booth. That's the tracking system finished. I just have the lower end, the bit that the wheel sits on, to finish. This is the spacers for the booth, tacked on to just 30mm box, tacked on. There's a stone now. So this is the 30mm box used for the booth, the spacers to bring the tracking system to the same height, level, plumb. This is the lower item or component used to carry the wheel, or any item such as a gearbox, covers or anything. At this stage you can still see that the oven at the back hasn't got the updated backplate for the back shield, the deflector. So, final images. Okay, so this is the back of the oven, finished. This is the front, mind the wall, it's all dirty. So this is the front, a close-up of the front. Another close-up. I'm going to show sample pictures of an alloy wheel that I got back from a professional company. That's why I built the oven. So the wheels come back all pitted, with marks in them like this. Orange peel, haze, flatness, dull, no finish at all in them. Really poor, from a professional company in Northern Ireland. So I stripped the wheels myself and built a basin. I blasted them with glass beads. These wheels is brand new. Keep in mind, this is the wheel in the oven being degassed. So at this stage it's the door shut, degassed, and laying. This is the powder applied. So there's a primer, base coat and lacquer. This is the wheel finished in my finish standard. You can see that there is no more pitting. There's no dirt. Inside the wheels exactly the same. This is 4 wheels with the tyres on them. Such a handling I had to get the tyres put on them, because I wanted to get somebody that knew what they were doing. I had to remove the weights and end up and do them myself, because they were all put on bent. Okay, thank you for watching everybody. Sorry it was such a long video, but a lot of work involved in this. There was 20 projects within one project, if you know what I mean. Come back soon for more interesting projects. The next project will be a J32A2 jewelry like decorative performance manifold. Thank you.